Hello children, this is Amita Dalvadi from JHB Private English School. In this video, you will learn about chapter number 1 Rational Numbers of Standard 8 subject Maths. Topic you will learn is Commutative Property. Children, let's recall the list of properties of rational numbers that you will have to learn in this chapter. First type of property is closure property. Second is commutative property. Third is associative property. Fourth is distributive property. Fifth is identity property. And sixth is inverse property. Now let's learn about commutative property. Commutative property shows that the position of numbers does not matter. That is, if you swap the position of the numbers, then also the result will be the same. Children, it means that when we change the order of the number, we get the same answer. So, now let's see commutative property of whole numbers, integers and rational numbers, of addition, subtraction, multiplication and division with examples. Let us start with whole numbers. Here 5 and 4 are whole numbers. 5 is at first position and 4 is at second position. So when we add these two whole numbers, we get answer 9. Now let's change the position of these numbers. Now we take here 4 at first place and 5 at second place. And when we add these two numbers, we get answer 9. Children, here we can see that when we change the number of whole numbers, we get the same result. It does not make any difference. So here we can say that addition is commutative for whole numbers. Now let's see for subtraction. Here when we subtract 4 from 5, we get answer 1. Now after changing the place, let's see what happened. Now 5 is subtracted from 4, we get answer -1. Here answer is different. When we change the position of numbers, we get different answers. So here we can say that subtraction is not commutative for whole numbers. Now let's see the example of multiplication. When 5 is multiplied by 4, we get answer 20. And when 4 is multiplied by 5, we get answer 20. Here, when we change the position of numbers, we get the same result. So, we can say that multiplication is commutative for whole numbers. Now, let's see what happened for division. Here 5 is divided by 4, we get answer 5 upon 4. And when 4 is divided by 5, we get answer 4 upon 5. And hence here results are different. So we can say that division is not commutative for whole numbers. Now let's see for integers. Here when 5 is added to -4, we get answer 1. Now let's change the order of these numbers. When -4 is added to 5, we get answer 1. Here we got the same result. So we can say that addition is commutative for integers. Now for subtraction, when we subtract -4 from 5, we get answer 9. And when 5 is subtracted from -4, we get answer -9. Here results are different. So we can say that subtraction is not commutative for integers. Now let's see for the multiplication. When 5 is multiplied by minus 4, we get answer minus 20. And when minus 4 is multiplied by 5, we get answer minus 20. Here, when we change the order of the numbers, we get the same result. So, we can say that multiplication is commutative for integers. Now for division. Here 5 is divided by integer minus 4. So we get answer 5 upon minus 4. And when minus 4 is divided by 5, we get answer minus 4 upon 5. So we can say that division is not commutative for integers. Now let's see what happens for rational numbers of addition, subtraction, multiplication and division, whether they are commutative or not. Let us start with the addition. Here 1 upon 2 and 2 upon 3 are two rational numbers. Here 1 upon 2 is at first position and 2 upon 3 is at second position. When we add these two numbers, we get answer 7 upon 6. Now let's change the order of the rational numbers. So when we write 2 upon 3 at first place and 1 upon 2 at second place, and when these two numbers are added, we get answer 7 upon 6. Here we got same result. So we can say that addition is commutative for rational numbers. Now for subtraction, 2 upon 3 is subtracted from 1 upon 2, we get answer minus 1 upon 6. And when 1 upon 2 is subtracted from 2 upon 3, we get answer 1 upon 6. Here results are different. So we can say that subtraction is not commutative for rational numbers. For multiplication, here example is given 1 upon 2 multiplied by 5 upon 3, so that we can get result 5 upon 6. When 5 upon 3 is multiplied by 1 upon 2, we get result 5 upon 6. Means here results are same. So we can say that multiplication is commutative for rational numbers. When 5 upon 3 is divided by 1 upon 2, we get answer 3 upon 10. Now, when 5 upon 3 is divided by 1 upon 2, we get answer 10 upon 3. Here, answers are different. So, children, we can say that division is not commutative for rational numbers. So, from these examples, we can say that addition is commutative for whole numbers, multiplication is commutative for whole numbers, but subtraction and division are not commutative for whole numbers. For integers, we can say that addition is commutative for integers, multiplication is commutative for integers, but subtraction and division is not commutative for integers. And for rational numbers, we can say that addition is commutative for rational numbers, multiplication is commutative for rational numbers, but subtraction and division is not commutative for rational numbers. So now children, we can conclude that addition is commutative for rational numbers. In general, it can be represented as a plus b is equal to b plus a. Subtraction is not commutative for rational numbers. Multiplication is commutative for rational numbers. In general, it can be represented as AB is equal to BA. Division is not commutative for rational numbers. So children, this all about the commutative property of rational numbers. In next video, you will learn about associative property.